Wait, this is question 7 on paper 1 for the 2017 A-level physics from AQA. This is a simple harmonic motion, or a periodic motion. Actually, it's not technically simple harmonic motion. It is periodic motion. Um, for a spring mass system is what we're looking at here. So we can see the signal generator is 2 hertz. We know that we have a maximum amplitude of 25 millimeters, and we've got a maximum kinetic energy of 54 millijoules. So we are going to rely on our formula sheet here. And what we need to know is that for this kind of system, Vmax is equal to omega times A. And in this particular case, our omega is... Where am I missing? Nothing in particular there. So omega is 2 pi f. So 2 pi. Frequency is 2 hertz. So times 2. And our amplitude, 2.5 times 10 to the minus 2. So Vmax is 2 pi times 2 times 2.5 times 10 to the minus 4. So 3.14 times 10 to the minus 3. Our EK max will be 1/2 mv squared V max squared. Okay, so 54 times 10 to the minus 3 is equal to 1/2 m times 3.14 times 10 to the minus 3 squared. So I rearrange that. M is going to be equal to 2 times 54 times 10 to the minus 3 divided by 3.14 times 10 to the minus 3 squared. That's not right. Oh, that's why. So it's just 0.3, so it's 0.314. That is what is known as a power of 10 error, my friends. Power of 10 error. So 1.1 kilograms, and that looks right. Okay, so mass is 1.1 kilograms. For K, the mass spring system, you've got period is 2 pi square root of m over K. So let's rearrange this. So I've got F, not T, so I'm going to change that. That's so square root of m over K is equal to 1 over 2 pi F. So, I'm trying to find K, not M, so I didn't rearrange that as well as I could have. So M over K is 1 over 4 pi squared F squared. So K is actually equal to, I'm going to go like this, 2 pi F squared times M. So 1.1 times 2 times pi times 2, 13.8 newtons per kilogram. And again, where am I off? What have I done wrong? Ugh, I'm an idiot. Squared. 173. So that's twice in this one question that I have made arithmetic errors, and because I'm just gonna say I've been doing this all day, so I am a little bit tired, and I guess I'm a bit off my game on this particular question. But those are the right answers now. That is the right process for it. Okay, calculate the frequency attached to the spring that B oscillates to with maximum amplitude. Okay, well, T equals 2 pi square root of m over K. And spring B is 3K. So the period is 2 pi square root 1.1 divided by 3 times 173. 2 pi square root 1.1 divided by 173. So that's 0.5. So F equals 1 over T. Is 2.0. Three point 3.5. So I immediately knew that was wrong without looking because that was the same one, and it's because I left out the 3. I am not doing well on this question so far. Okay, so 3.5 hertz. Mark scheme. Oh, thank God I caught my error in time for that one. Okay, so this shows how the amplitude of the oscillation varies with the frequency for spring A. Okay, so this is about dampening. All right, so dampening. With dampening, you are going to have a different graph. So two differences in this graph. Well, number one, the peak will be much lower. You're going to flatten that curve. Okay, so the peak is lower. Okay, so because it's damped, it's going to be a lower maximum amplitude. Okay, and difference two is that damping is going to move the peak to the left. I'm pretty sure it's to the left. Okay, so it won't be at the natural frequency. Okay, let's see what I've missed out from an answer there. Oh, I didn't even read the question. Okay. So, this really, really aggravates me, but it's important that you see me make mistakes, and it's important that I don't pretend like I never make mistakes. So, here, this is a graph for spring A. So what is it going to be for spring B? Well, so because you have a higher spring constant, you actually end up with it's a higher frequency for the maximum amplitude. Okay, the peak is broader. It has been flattened because it has been damped. The other thing is that it will be a lower. The graph will be lower at all frequencies because you have the damping in place. So you got energy losses in the system. So yeah, I'm gonna stop there, and I think I'm going to wait until tomorrow before I do the multiple choice because the number of mistakes that I am making right now is atrocious.